There are a couple of special right triangles. We call them special because they special. You don't even need the trig functions to solve them. One of them is the 45, 45, 90 triangle. Here's why we call it that. Let's suppose we start with a square. Now, there are some properties that we know of a square. We know that every angle is 90 degrees. I'm just going to mark one. We know that they're all the same. And we know that every side is the same. Let's say for the purposes of this, we're going to say these side lengths are all 1 unit. All right, so we've got that. Let's take a diagonal and draw it from one corner to the other corner. You see, we've made two triangles, and both of these triangles are going to be equal to each other. We can talk about why later, but we've made two triangles. Let's focus on that top triangle that we have. So I'm going to erase this right here. Now, this diagonal that we made, we just cut that angle in half. So this is going to be 45 degrees because 45 is half of 90. This is also going to be 45 degrees. And this, to find this side, we can do the Pythagorean theorem. So Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. So 1 squared plus 1 squared equals c squared. 1 times 1, or 1 squared is just 1. So 1 plus 1 is 2. So 2 equals c squared. And we take the square root of both sides and we get the square root of 2 equals c. And so that means that this hypotenuse in this case is going to be the square root of 2. Well, here's the thing. Anytime we have a 45, 45, 90 triangle, it's always going to fit this same ratio. So let's try. Let's say we know that we have a 45, 45, 90 triangle. Let's call that, and 45 and 45. And let's say this one is going to be 17. Let's say they only give us one side and say it's 17. Well, we know a 45, 45, 90 triangle. Well, if this angle is equal to that angle, then that means this side is equal to that side. This is 17. And it also fits this ratio. These legs are the same. And in order to get from the legs to the hypotenuse, we multiply the leg by the square root of 2. Because see, that's 1 times the square root of 2 in order to get there. So we do the 17 times the square root of 2. And that's it. Now, let's imagine they tell us we have a 45, 45, 90 triangle. We can just say that and that. Because if it's 90 degrees and those two angles are equal, they've got to be 45. And let's suppose that instead they give us the hypotenuse. The hypotenuse is 8 square root of 2. Well, if in order to get from the leg to the hypotenuse, we multiply by the square root of 2, then that means to get from the hypotenuse to the leg, we divide by the square root of 2. 8 square root of 2 divided by square root of 2, well, those square root of 2's are going to cancel out. I can show that right here. 8 radical 2 over radical 2. Well, that canceled out and that canceled out. We're just left with 8. So that being the case, if this is 8 radical 2, this leg is 8, this leg is 8. And it's always going to fit that proportion there. This legs are equal, and hypotenuse is leg times the square root of 2. That's why it's special. You don't even need the trig functions.